Hello everybody, this is Rochan here. So today let us look at a small topic that is allied angles from the chapter Trigonometry. Very important, we use it almost in many questions of trigonometry while proving whether it is to find any value of any sine function, etc. Right? So what is this allied angle? So if I consider some theta, some angle theta. So for some angle theta, what all can be the allied angles? There is a general formula for that, n pi by 2 plus or minus theta. N pi by 2 plus or minus theta can be the general, this is the general form of allied angles. This can be the allied angles where n belongs to integer. Okay, now let me just put n is equal to 0, then this whole term becomes 0. I'll be left with plus or minus theta. This is an allied angle for theta, right? Now let me put n is equal to 1. I'm going to get pi by 2 plus or minus theta. See, what is pi by 2? Pi by 2 radian is nothing but 90 degrees. So I can write it as 90 plus or minus theta. Now let me put n is equal to 2. 2 gets cancelled. I'll be left with pi plus or minus theta. Pi is 180 plus or minus theta. So similarly for other values of n, I'll be getting I'll be getting some values. So these all values are going to be the allied angles for this angle theta. That is all about allied angles. Now with respect to quadrants, when I just use some trigonometric function to these allied angles, what changes do I expect? That we are going to see now with respect to quadrants. Say if I take sine of 360 plus theta, what am I going to see? What will the value change on the RHS? So that we will look at it now. Okay. Now, before I go with the quadrant, the explanation, just remember that sine of minus theta is minus sine theta, right? Cos of minus theta is just cos theta, and tan of minus theta is going to be minus tan theta, and even the reciprocals of each. So cosecant of minus theta is going to be minus cosecant theta. Then secant of minus theta is going to be just secant theta, and cot of minus theta is going to be minus cot theta. Just as a note, you can remember this. Okay, yes. Now let us go to the quadrants. Just considered the coordinate system, right? X dash, y dash. Okay, these are the two axes meeting at origin. Now we know this is the first quadrant, second quadrant, third quadrant, and fourth quadrant. This is perpendicular, mutually perpendicular, right? So from here to here, from x, what is the angle XOY? 90 degree. What is the angle YOX dash? 90 degree. So all are going to be 90 degree. So angle XOX dash, that is this whole angle is going to be 180 degree. Very well understood. We all know this, right? Now, in the first quadrant, how can I represent the theta? Now see, I can write in the first quadrant, I can write theta in the form of 360 plus theta or 90 minus theta. How can I write this? Now I told you these are mutually perpendicular, right? So this whole, if I complete one whole round, I am going to get 360 degree, right? 360 degree. Now for this, let me add some angle. Let me add some angle theta. So can I write this theta as 360 plus theta? So any angle that is in the form 360 plus theta is going to lie in the first quadrant. That is what it means. Now similarly, if I just take, sorry, if I just take this is 90 degree, right? And 90 degree, if I just subtract some angle theta, if I just subtract some angle theta, that also is going to lie in the first quadrant itself. So some 90-degree minus some angle theta will be always in the first quadrant. Okay, theta will be almost between this, right? So if you take 90 minus some 89 degrees, that will lie in the first quadrant itself. Okay, so if you take 360 plus 1 degree, that will lie on the uh, that will lie in the first quadrant itself, right? Next, similarly, second quadrant, I can represent it as 90 plus theta. This is 90 plus theta. Or what is this angle XO X dash? 180 minus theta also I can represent it as, correct? 180 minus theta, the same logic, right? Now let me go to the third quadrant. I can write it as 180 plus theta or 270 minus theta. This XO X dash is 180 plus theta will lie in the third quadrant. Or if you take the angle XO Y dash, that is 270, and some minus theta is going to lie in the third quadrant itself. Understood? Yes. Similarly, the fourth quadrant can be 270 plus theta and or 360 minus theta. The same logic. Okay, so these are the allied angles for theta, which we will concentrate, mostly we will concentrate on these angles. Now, what is going to happen if I apply trigonometric functions to these angles? Let us see. For that, we have to remember a small rule which is called cast rule or ASTC rule. ASTC or CAST. Anyhow, you can remember. Now, what does A imply? All. S implies sine and its reciprocal function, that is cosecant. T is tan and cot. C is cos and secant. Now, what does this mean? If I take some trigonometric function of these two angles in the first quadrant, it is always going to be positive, like sine of 90 minus theta. If I take the value which I get on RHS will be positive. Or if I take sine of 360 plus theta, the value which I get will be positive. If I take cos, if I take tan, if I take cot, any function, all I'm going to get is positive values. Okay, this is about A. In the first quadrant, all trigonometric functions of these two angles are going to be positive. Okay, now coming to the second quadrant, yes, very simple. In the second quadrant, if I take sine of 90 plus theta, sine of 180 minus theta, and cosecant of 90 plus theta, and cosecant of 180 minus theta, only for these values I'll be getting positive values. If I take tan, if I take cot, if I take secant, cosecant, sorry, if I take secant and cos, for these values I'll be getting negative um, in the RHS, negative answers. Okay, so similarly in the third quadrant, only tan and cot will be positive. Tan of 180 plus theta, positive. Tan of 270 minus theta, positive. So similarly, in the fourth quadrant, only cos and secant is going to be positive. So cos of 360 minus theta, secant of 360 minus theta, cos of 270 plus theta, secant of 270 plus theta, all are going to be positive. Only these four quantities in the fourth quadrant, right? So that is about ASTC rule, where you will take positive and which function you will take negative. That we have to remember very well. Now let us just apply sine functions and cos functions and see. Another rule which comes while solving problems is going to be this. So let me just give an example. take sine of 360 plus theta and sine of 90 minus theta. Let me consider the first quadrant. Now we know sine of all functions will be positive in the first quadrant. So sine of anything will be positive. It will be positive in the first quadrant. How do we know it is a first quadrant? Because 360 plus theta and 90 minus theta are in the first quadrant itself, right? So check that first. Now, can I just write this as sine theta here also and sine theta here also? No, I cannot write it. Why? Because there is another factor which we have to look at before coming to conclusion. Now just see 360 and 90. What is the difference? 90, can I write it as 90 into 1? 360 I can write it as what? 90 into 4, right? I can write 360 as 90 into 4. 360. Now 90 is multiplied by 1. 90 is multiplied by 4. 90 is multiplied by 1, I'm getting 90. 90 is multiplied by 4, I'm getting 360. So here 360 is an even multiple of 90 or pi by 2. 360 is an even multiple of pi by 2. That is why what we have to do is, if there is any even multiple of pi by 2 here, we will just keep the same function and write with that we'll write theta, sine theta. So sine of 360 plus theta will be equal to plus sine theta. Understood? Now take 90 into 2, that is 180. So anything, for example, let me consider second quadrant now, 180 minus theta. Sine of 180 minus theta is in the second quadrant. And in second quadrant, we know sine values will be positive. So put a positive sign. 180 minus theta, just see this value now. 180 is even multiple of 90. So sine will remain as it is and you'll write sine theta. Okay. Now what if it is an odd multiple? What should we change? There is a rule for that. So if the inner, the degree is odd multiple of 90 or pi by 2, the functions will get changed. The functions will get changed. How is it going to change? Very simple. Sine is going to change into its co-function, that is cosine. Sorry, yeah, cosine. What we write it as cos. Now, next one. Secant is going to change into its co-function, cosecant. Tan is going to change into its co-function, that is cot. So why have I put double arrow headed line? Because it can be both the ways. If there is cos of 90 minus theta, say, because the angle is the odd multiple of 90, cos can change to sine. I mean, it will change to sine. Okay, and secant will change to cosecant and vice versa. Tan will change to cot and vice versa. This is what happens. So this you have to note. When the angle inside this one, I'm talking about the first angle here, leave theta. So when angle is odd multiple, odd multiple of pi by 2 means 90 degree, then the function is going to change. Now let me just keep this here. Now let me consider the same question. Let me erase this. Let me consider sine of 360 plus theta. Now, according to what we have learnt, sine of 360 plus theta. First step, see where is this 360 plus theta. It is in the first quadrant. So don't worry about the sign because all are going to be positive. The sign of RHS, whatever value we get, it is going to be positive, right? So don't worry about that. And now see the angle here. It is 360, even multiple of 90, correct? So sine will remain as it is and theta. Now take sine of 90 minus theta. Here it is going to change. Now first step as usual, see where 90 minus theta lies. It is going to lie in the first quadrant. Because it lies in the first quadrant, all are positive. So sine of this 90 minus theta will give you a positive value. But now see this inner angle. It is 90. It is an odd multiple of 90 degree, correct? 90 into 1. 1 is odd number, correct? So sine will change to what? Cos theta. Understood? So sine of 90 minus theta is not plus sine theta, it is plus cos theta because 90 is odd multiple of pi by 2 itself, odd multiple of itself, correct? Now to understand better, let us take few more examples. Let me go for the second quadrant, 90 plus theta, sine of 90 plus theta. Now just see 90 first step as usual. See 90 plus theta, it lies in the second quadrant. In second quadrant, sine is positive, so put positive. Now 90 is, now just see this angle, 90 is odd multiple of itself. So sine will change to cos, it is plus cos theta. So sine of 90 plus theta is going to be also plus cos theta. Understood? Now let me take some random example. Tan of 270 plus theta. First step, see where is 270 plus theta. 270 plus theta is in the fourth quadrant. And see in fourth quadrant, only cos and its reciprocal secant, correct? Cos and secant is going to be positive, which means tan is negative. Put negative sign. Now see this angle. 270 is odd multiple of 90, correct? 90 into 3 is 270. 3 is odd multiple, odd number, sorry. So 270, since it is odd multiple of 90 degree, tan is going to change to its co-function, that is cot theta. Okay, this is all about allied angles, very simple. Just that first step you have to see in which quadrant the angle lies. Second step you have to see what are the functions which is positive in that quadrant. Third step you have to see whether I should change this function or not change. How do we get to know that if angle is odd multiple of 90, the function will get changed to its co-function. Okay, if it is even multiple of 90, the function will remain as it is, no change. Okay, I hope this is clear. Let us look at a few more examples. Now this you have to try and recollect in your mind itself. Let us take a simple one, cos of 180 minus theta. So first step, 180 minus theta, imagine it lies in the second quadrant, right? 180 minus theta lies in the second quadrant. And in second quadrant, what all is positive? ASTC rule, AS. So sine and cosecant is going to be positive, correct? So cos is going to be what then? Negative. Put negative sign. Now see second step. See whether where is this angle? This sorry. If this angle is odd or even multiple of 90. See that. So 180 is even multiple of 90. Correct. 90 into 2 gives 180. So you need not change the function. Function is going to be same cos theta. So cos of 180 minus theta is minus cos theta. Now let us look at another example. Let me take cot of cot of 360 minus theta. Let us see this. Now 360 minus theta. In which quadrant is it there? Fourth quadrant. So in fourth quadrant, which all functions are positive? A, S, T, C. So cos and secant is positive. So which means cot is negative. So put negative sign here. Now come to this. 360 is even multiple of 90. 90 into 4 is 360. 4 is even. So cot is going to remain as it is. So cot theta. Now another example, let me check for secant of 270 minus theta. See, secant, now come to 270 minus theta. 270 minus theta, imagine it is in the third quadrant. It is in the third quadrant. Okay. Next, what are you going to see if we have to put plus or minus? In third quadrant, AST, tan and cot are positive. Secant is negative. Just put minus. Okay. Next, see this angle. 270 is odd multiple of 90. 90 into 3 is 270. So 3 is odd, which means if it is odd multiple, secant will change to its co-function. So cosecant theta it is going to become. So secant of 270 minus theta is minus cosecant theta. So like this, if you write sine, cos, tan, cot, secant and cosecant for all angles, what was 90 plus or minus theta, 180 plus or minus theta, 270 plus or minus theta, 360 plus or minus theta. For all 8 angles, if you write all the 6 functions and just make a table and keep it and revise it every day, it will be more clear. No need to by heart, you just have to know the 3 main steps, what to do, when is it positive, when should I change the function, etc. So if you know this, your work is going to be very easy. Even while simplifying in a very proof questions or any, if you have to find any measure of some angle, even then it is going to help. Just remember the ASTC rule for to see which sign to give, plus or minus sign. And remember this odd or even multiple of 90 concept to see whether the function should change into its co-function or not. And you have to remember the quadrant angles, which angle lie in the which quadrant. So that's all about allied angles. I hope you all have understood. Thank you so much.